All right, so in this unit, we're gonna learn about a concept known as the mole. And a mole, it sounds a little weird and intimidating, but it's basically just a word that represents a number in chemistry, right? Because atoms are so tiny, we need a number to represent the sheer quantity of atoms and molecules we're dealing with. And so we actually are very familiar with using words to represent numbers. So let me give you a couple of examples here. If I told you, for example, I have 1 dozen eggs, we know how many that is. That is 12. Right? We've got 12 eggs. What if I tell you you have a baker's dozen? Maybe you're a little less familiar with this one, but a baker's dozen, okay? A baker's dozen is when a baker gives you an additional one for your walk home. So that's going to be 13. Let's say it's 13 donuts. All right, let's talk about some other words that represent numbers. A pair. So if I tell you I have 1 pair, how many do I have? Well, I've got 2. Right? So normally we refer to a pair when we're talking about shoes, but I could say I have a pair of brothers or I have a pair of calculators. That represents 2. A couple of other ones you might not be so familiar with. A gross. So this comes in when we're talking about, for example, pencils or something that's smaller, but a gross is 144. Okay, so it could be 144 pencils. If I want to have a gross of chickens, I could have 144 chickens. Another one, a ream, right? Normally we refer to a ream of paper. That's that huge bunch of paper that's covered in plastic. A ream is exactly 500 sheets of paper, but it doesn't have to refer to sheets. It can refer to, I don't know, rocks. I have a ream of rocks, right? I have 500 rocks. So these are all words that represent numbers. All right, so let's look at an example of how to convert using the setup that we use when we are working with unit conversion. Okay, so if I tell you I have 50 nails and I want to know how many dozen nails that is, I know you can do that in your head and figure it out by dividing and you've got your answer, but we're going to get quite a bit more complicated, so I want to make sure we have the correct setup here. So if I tell you I have 50 nails here, right? How can I figure out how many dozen nails that is? Well, let's work on the setup with the crisscross swoosh that we did before, right? You've got nails on the bottom, okay? And then you've got dozen on top because those are the units you're trying to get into. So nails on the bottom so that nails will cancel, dozen on top. Well, what is this relationship? Well, I know that 1 dozen is 12. So all you're going to have to do now is in your calculator, take 50 and you're going to divide it by 12. And what I get is 4.17 about. And notice I tell you not to worry about sig figs for these numbers or for these questions because 50 nails is actually counting. So that doesn't have a specific number of sig figs. It's actually infinity beyond the scope of what we need to be worried about. What I care is that you understand this conversion. So about 4.17 dozen nails is 50 nails. All right. Well, let's actually put this into chemistry terms now. All right. So what the heck does the mole mean? What is the mole? Well, the mole is represented by Avogadro's number. So Avogadro's number is a very large number. It is 6.02 times 10 to the 23rd. So this number, just like a pair can represent a pair of eggs or a pair of shoes or a pair of weights or whatever you want, this number can represent a number of things. It could be 6.02 times 10 to the 23rd formula units, right? And formula units, this is used when we are describing ionic compounds, right? Compounds that have ionic bonding, which would simply be a compound that has a metal and a non-metal. Remember that from last semester, okay? Or I could have 6.02 times 10 to the 23rd molecules. And that would occur when I have a covalent compound. Remember, a covalent compound is going to be one that has 2 nonmetals. All right? And then finally, I could have 6.02 times 10 to the 23rd atoms. And that's when you simply have an atom all by itself, one single atom or element. Okay, so where does this word, the mole, come from? Well, if I tell you I have 1 mole of, for example, in this case, sodium chloride, NaCl, since NaCl is an ionic compound, I would say 1 mole of NaCl is 6.02 times 10 to the 23rd formula units. And it's called the formula unit, guys, because for an ionic compound, it creates this gorgeous crystal structure, and they're all combined together. You don't have individual molecules like you do here with a covalent compound. It's basically this crystal that has trillions of ions combined together that are attracted to each other and oriented in this fashion. But the purpose of this is to say 1 mole of sodium chloride is 6.02 times 10 to the 23rd formula units. Or if I have 1 mole of carbon dioxide or water here, that means I have 6.02 times 10 to the 23rd molecules. Or if I have 1 mole of gold here, I have 6.02 times 10 to the 23rd atoms. All right, so this number, Avogadro's number, shows us just how huge the number of formula units, molecules, or atoms are going to be. Why? Because those formula units, molecules, and atoms are very small. So let's practice with this. If I have 1 mole of sodium, what that tells me is that I have 6.02 times 10 to the 23rd, well, what? Well, if it's just sodium all by itself, then that's going to be atoms. All right. If I have 1 mole of sodium phosphate, remember sodium is a metal, okay? So I'm going to have 6.02 times 10 to the 23rd. If I have a metal with a polyatomic ion, that is going to be an ionic compound. So I have 6.02 times 10 to the 23rd formula units. If you want to abbreviate formula units, you can write Form U. Please don't just write F followed by a U for obvious purposes, or if you want to write formula units, that's fine as well. If I have 1 mole of carbon dioxide, what that tells me is I have 6.02 times 10 to the 23rd molecules. And I'm going to simplify that by writing MOLEC. Okay? Now, why do we care? Well, now we can take a specific number of moles of an ionic compound, a covalent compound, or an atom, and I can convert that into atoms, formula units, and molecules. So let's look at this example here. It says how many molecules are in 2.12 moles of C3H8. So my given here is 2.12 moles, and I want to get into molecules. So what I'm going to do is I am going to put moles on the bottom because that's what I'm trying to get out of. And I'm going to put molecules up top because that's what I'm trying to get into. Okay, well, what's the relationship between moles and molecules? Well, I know that 1 mole of C3H8 has 6.02 times 10 to the 23rd molecules. All right, so that's all that's new, this relationship here, this Avogadro's number, right? So 1 mole is what? 6.02 times 10 to the 23rd molecules. Just like if I had written 1 dozen is 12 nails or 12 shoes or 12 eggs or whatever that might be. All right. So what we're going to do now is we're going to take 2.12 and we're going to multiply it by 6.02 times 10 to the 23rd. All right. And what I get unrounded is 1.276 times 10 to the 24th. That is a lot of molecules. So that shows you just how tiny your molecules are, that you can have that many molecules. All right. So I now need to round properly. So I've got 2.12, which has 1, 2, 3 sig figs. So my final answer needs 3 sig figs. 1, 2, 3. I'm going to round the 7 up and I get 1.28 times 10 to the 24th. And my units are molecules. Okay? And that is your answer.